Hello, and welcome to this SAMK tutorial. Today we're going to solve the NAFENS LE10 benchmark. Here we have the CAD file in step format. The problem asks for linear elasticity, so there we go. It then says what the boundary conditions are. Uniform normal pressure of 1 megapascal on the upper surface of the plate. This face DC-DC has to have 0 Y displacement, which is fixed V. This one AB-AB, 0 U. This one BC-BC, 0 U and 0 V. Finally, this edge, 0 W. Now, material properties. Isotropic elastic. Young modulus, 210 gigapascals. Uniform. Poisson's ratio, the good old 0.3. And we're done. Okay, first thing. The mesh looks coarse, doesn't it? But there's something else we can do before refining. The problem asks for the normal stress in the Y direction evaluated at point D. We would use probes to get this result, but that feature is still not implemented. Instead, we're going to ask for that value directed to the solver. Let's go back to the problem step. Let me explain a little technical detail. These choices for boundary conditions and material properties are stored directly in the Phenox input file. So if I change something here, it will be reflected in the input file. And the other way around. If I edit the input file, the UX will reflect that, as long as it understands it. But also, it means we can add custom instructions here. Let's ask Phenox to print out the requested result, namely sigma y at the position of point D, which is 2 meters 0, 300. If we now solve, we get the same as before, but also this console output down here with the result. Let's refine the mesh to see if we can improve that number. Remember, the reference result is 5.38. First thing we can do is perform a global mesh refinement. The thickness is 600. Let's choose 150. Better, but we can still improve. Very much like for the solver, the meshing settings are stored in the GMesh's input file in geo format. We can edit the mesh size in the file, say 200, and the UX will reflect that. And again, we can enter settings which are not yet supported by the UX. In particular, we want to locally refine around the point where we evaluate sigma y. I already have the needed lines in order to refine locally around point D. We can see that the mesh is indeed refined around the point of interest. Let's solve again. The actual result is not important here because we were far away from the converged mesh. That was it. Let me know in the comments if you have questions or something you'd like me to discuss in other videos. Thanks for watching.